watch this. Okay. The recording our review of SAT practice test number 1 that comes from the College Board website. Here we're looking at section 3, the math section without a calculator. And we're just going to talk about a few questions in this section and go over some other sections. So as you would imagine, the first question usually should be pretty straightforward. Here's a case 3. You don't just solve for x. So, using a golf analogy, I would consider it's like basically less than a 1 foot putt. You just tap it in, so it shouldn't be that hard. X minus 1 over 3 equals 3. You could plug into choices and get a match, and 10 would work for us. If you plug in 10, 10 minus 1 is 9. 9 over 3 is 3. Or instead of looking at a choice, you could just solve it by multiplying both sides by 3 and adding 1. So that's D. So again, those are kind of gimmies. Number 2, I'd say, is also a gimme. Now, if you are a junior, you probably have, at the very least, done Algebra 2. The concept is covered Algebra 2, probably in the fall. And that's called the complex number. So all they're really asking you to do is just add this complex number to the other complex number, meaning you combine like terms. 7 plus negative 8. And of course, 3i plus 9i. You get negative 1, you get 12i. So there you go. So as you can see here, they're really kind of trying to keep things very conceptual. Like, can you solve an equation? Can you, combine complex numbers, things that we totally have done in school. So that's why the answer is A. Now, things can get a bit abstract. And actually, I'm going to kind of stay on this page here and then jump to the hard problems. Number 3 is something we don't do necessarily in high school math curriculum. You have these variables represent different things, like Armand sends M text messages each hour for 5 hours. Tyrone sends P text messages each hour for 4 hours. Okay. So what represents the number of messages both of them send on Saturday afternoon? Okay. Let's say Armand sends 10 text messages, but each hour for 5 hours. So that's 50 messages. So you just got to read carefully. Let's say Tyrone does 20, again, each hour for 4 hours. So that's 80, 20 times 4. So obviously it adds up to 130. Well, if you think about what I really just did was multiply M by 5 and P by 4 and add it up. So that's why it's C, but you could check 5 times 10 plus 4 times 20. So you get 130. That's all. So they like using variables in the choices, and this is one of the easier ones, but we'll look at a harder one in just a couple minutes. Now here, this is an interpretation problem. What is the meaning of some number in an equation? So you have to interpret correctly. They love this kind of stuff on the SAT. Now actually, we have been spending some time on this in our high school math curriculum. You really want to understand in context what's going on here. And don't overthink it. Remember, it's number 4. So they say that Kathy's a repair technician for a phone company. I really don't care about Kathy or where she works, so it's not really relevant. Each week she was asked phones that need repairs. I don't care either about that. Now this I do care about. The number of phones that she has left to fix at the end of each day can be determined or estimated with the following equation, where P is the number of phones left and D is the number of days she has worked that week. Think of it as Y equals MX plus P, if that helps. They love having to interpret linear equation. That's really what this is. So you can think of P like Y and D like X. So if I were to kind of rewrite it or kind of stack it right below, P equals negative 23D plus 108. So the negative 23 is actually a slope. And then 108 is the y-intercept. In fact, actually, you can make even a table. like an XY table or DP table, if you want to call it that. Like she doesn't work it yet, then she has 108 phones left to fix. After 1 day, then she gets 85 phones to fix. So it goes down by 23. After 2 days, this is non-calc, by the way. So if you do negative 46 plus 108, I think you get 62. So the slope, negative 23, represents the change in how many phones she has left per day. So that is what a slope is anyway, right? Change y or change in x, or to change in price, sorry, change number of phones over the change in days. But the 108 is what she starts with, and that's what we're going to go with. So starts each week 108 phones to fix. Totally, that makes sense. It's y-intercept, right? And y represents phones, so it's not going to do anything with time. And it's not a rate. That's rates are slopes. That's why it's b. Now, if they ask what negative 23 represented, then I would have chosen D with a 23 there. So I'll be curious when I look at the data, what problems you guys are missing. And if I see this as a common theme, it means that I have to spend more time giving you guys practice with this. And it's not hard because you guys know about linear functions. It's sometimes you never really assess this way, but I think we're trying to do that more often in the Sacred Heart Math department. I'm going to jump around now. Let me jump to both 9 and 10. This is another common theme. Systems of linear equations, which was covered, I believe, in the fall. In Algebra 2, if you were in Algebra 2. Pre-calculus, we kind of just assume that you're comfortable with this by that time. Algebra 1, of course, this is a big part of it. If you did a placement test, when you got into Sacred Heart, we'd always assist knowledge of this stuff. So here they want for number 9. And by the way, if you have any questions, feel free to type in the chat or speak in your microphone. If you see a question on the page here that you really would like me to go over and I'm not talking about it. So you could do this a couple of ways. Actually, more than a couple of ways. You could approach this graphically. You could use something called a matrix. But we're just going to do one of two techniques. Either elimination or substitution, really whatever you're comfortable with. Like if I do substitution, I can isolate x here and divide by -1. Okay. Let's substitute the equation. You just work it out. And once you get what y is, then you can continue solving by plugging in for y into this equation and solve for x. So y is -8. If y is -8, x is 3, and there, and there you go. And that's what b. Another way you could approach this too is you could have plugged in numbers, like plugging each of these choices, like plugging 3 for x, -8 for y, into each equation and pick the choice that works for both equations. There is multiple choice. You could always work backwards. Another way you could approach this too, you could have done a process called elimination. Where you stack the equations like this and then maybe multiply the second equation by 3. Then things go away. So you get 3x plus 4y equals -23. And -3x plus 6y equals -57. And then if you add the equations, sorry, I'm like losing my voice, 10y equals -80. So y equals -8, then plug into either equation to solve for x. You could do that. That's a possibility too. And they put this in non-calc because there is actually a feature in the calculator that the TI-84 calculator that can solve system equations pretty quickly, or you can graph them. Like you can isolate y in each case and then find a point of intersection. College Board knows this, which is why they put it in non-calc. Now here's another one, also involves a system. So here they ask you, they tell you the equation for the price of beef and chicken. X number of weeks after July 1st or last summer, fine, whatever. So the price, I think, will go up after July 1st, which kind of makes sense because you're in the summer months and people want to barbecue, I guess. I don't know. Let's live in California, we have wildfires that you can't be outdoors. Hope that's not so bad this year. Anyway, I digress. You want to know whether the price of beef and chicken are the same when B equals C. So there you go, just set them equal to each other. Now it's a little bit nasty with the decimals, but don't worry. Just be careful. My guess is to really kind of test you on your decimal arithmetic. Like the 0.25 can go from left to right to get 0.15x. The 1.7 can move from right to left to get you 0.6. X is 4. But then what they really want is a price of each when they're equal to each other. So we'll say I plug 4 into this one. 1.75 plus 0.8, sorry, plus 1.6. You get 3.35. So there we go. So again, those are common problems. Let's talk about functions. Sorry, that was 9 and 11. I thought that was in number 10. Let's talk about number 10 because they love functions. And I'll definitely do 13, 14, 15 as well. And then we'll move on to the math part with the calculator. So function notation is something we do talk often in Algebra 2 and pre-calculus. And again, you know, and my one concern with math is that, you know, we have this really weird schedule where some of you may have had math in January or February, and then the math since then. You know, we go into the dog days of summer, and still no math. And we don't know what the fall is going to look like yet. You know, I think hopefully by June we'll have some sort of announcement, but that's a long time not really being around math. And you know, sometimes math can have really weird notation. This is what we call function notation. It's not hard once you kind of get the hang of it. And again, I would call this a gimme for sure. All this means is that x equals 4, y equals 8. That's all it means. Because again, x is in the parentheses, and this right here is what y equals. I mean, if you really want to, you could just say y equals ax squared plus 24, right? So I'm going to plug in 8 for y and 4 for x and work it out and solve for a. It's 16a. You get negative 16 on this side if you move the 24 from right to left. So a is -1. That was important because now we have the equation in a more explicit manner. Now I know what a is, so it's negative x squared plus 24. And they want the y value when x equals -4. So I don't know what the y value is when x equals -4, so let's plug it in. Be really careful. PEMDAS, right? So -4 squared is 16, -16 plus 24 is 8. There we go. So you get in. That's all. And again, if that's something I'm noticing you guys are missing a lot of, then maybe I'll give more practice so you build up your confidence. That's why we do practice, so I can kind of diagnose what specific question types you might be missing and just give you crazy amount of practice with that. And that's what I think I will do with you two guys, since you're here. Thank you for showing up. But I'll set your exams first, and I'll kind of give you some things you probably could do over the next few weeks. And of course, if we are taking in June, great. If not, then we keep working until the fall. Now, we get to the last three multiple choice questions, 13, 14, 15. And remember, there's still 25 more questions after that, 16 through 20, but these are free response. And again, they kind of get easier. Well, they do get easier. Like this one's pretty straightforward. Well, t squared equals 4, t is 2. Like 16 is much easier than 13, 14, 15. So if you get stuck on maybe the last three multiple choice questions, maybe you could do some of the free response, come back to these later, because these do look a little nasty. And a lot of times they make them nasty just because they cover more advanced topics, like this is on rational functions, this is on quadratic functions, 14 is on exponential expressions or functions. So those are clearly dominant Algebra 2 topics. Well, let me tell you strategies we can use. I'm going to use strategy for all three of these. And I'm also going to get away from the conceptual approach. They said x is greater than 3. Make it 4. Why not? Nothing wrong with that. And plug it in. One up top, you get 1/6 plus 1/7. Okay. You could have fractions. I know you guys done that. So just do it. Just have the fractions. And again, don't stare at the problem. Don't, like, a lot of times we look at it and we're like, oh, like we get nervous. And I honestly, this is totally a mindset thing with the SAT. It's yes, it can seem daunting, but staring at it doesn't get us anywhere. So you really want to, and I'm just, when I'm talking about these scenarios, I'm just using anecdotes from my experience of covering this exam for the last 20 years. We just got to be persistent. Just try something. Like, okay, well, what if x is 4? What happens? Okay, I combine those fractions. Sure. So you just got to just be aggressive and try stuff. So you get 7 over 42 plus 6 out of 42, 1 out of 13 out of 42, and because it's 1 over a fraction, you flip it over, 42 out of 13. Now plug 4 in each choice. That's just 13. That's 16 plus 20 plus 6. That's 42. This is going to be 13 out of 42 if you were to plug in 4 for x. This will be 42 out of 13. When you plug in 4, you get 16 plus 20 plus 6. So you get A. Now, if you did approach it algebraically by, and again, this is the sad part of our Algebra 2 programs, that we had to rush these things like within a day or two, which I really don't like. But I mean, you could do that, but honestly, when you see letters in the choices, we should just substitute. Kind of like what we did for number 3 here. And I'm going to kind of keep that strategy for these other problems. It doesn't work all the time, but when you see letters, that's a good opportunity to use a strategy. For example, they tell you 3x minus y equals 12. They want to know the value of this. Well, let's make up something for x. Let's say x is 4. And y is 0. Because I forcing this to work. Great, it works. 12 equals 12. Awesome. Great. Now just substitute. 8 to the 4 power over 2 to the 0 power. Anything to the 0 power you should know is 1. Now let's look at the choices. Do I see 8 to the 4? Not exactly, but I definitely know it's not 8 squared, right? 8 squared and 8 4 are not the same. Definitely know it's not 4 to the 4. 8 to the 4 is not 4 to the 4 power. Cannot be determined. Well, we do have an answer, so I'm not sure if I'd want to say that necessarily. This is where you have to get a little creative now. It's a little conceptual. 8 hopefully knows 2 cubed. because 2 times 2 times 2 is 8. And you have a 4 on the outside, you can use your property of exponents by multiplying those exponents. Whenever you raise a power to a power, you multiply the exponents. So it actually matches with A. And that's your answer. So again, I use a substitution strategy. Didn't quite get the answer, but if I did a little manipulation of the base and use my properties of exponents, I got a match. And there I go. You could have also approached it algebraically too. I guess suppose you could have said, I mean, you could have done that and use properties of exponents again. And 3x minus y is 12. So that's yet another way you could have approached it. But you'd have to realize that you're testing a property of exponents. And this is why SAT prep takes, at least a couple months if you do it right, because you want to see a common theme. You'll start to see these problems over and over again. You start realizing, oh, okay, well, my tutor or my test prep instructor showed me this way of approaching this problem. So if I see it again, oh, maybe I should try that way. Maybe I should try changing the base. And that kind of, that exposure familiarity helps a lot. So that's really kind of what test prep does, for, to be honest with you. It's really just expose you as many question types as possible and start noticing patterns with particular question types. Of course, the issue that we've had in the last 14 months, people would prep for a certain day, then the rug will get pulled up from underneath them because the test will get canceled, and then it just kind of messes with the whole timing of things. But anyway, I'm hopeful that we won't have that problem going forward. 15. This is the last multiple choice question in this group. It's a tricky one. Now this one, I would probably be understanding. Yeah, like I'm not really sure what to do here. This could be really abstract. But here's the thing with the SAT. When you start doing that practice, when it says something is true for all values of x, what it means, they actually literally mean that. It means that if you put in anything for x, the left side will always equal the right side. Let's get a little bit more technical here. Let's say I give you these two statements. This I call an equation. This I call an identity. So why am I calling the second one an identity? How come I'm not calling the second one an equation? Because there's an equal sign, right? Well, an equation is something you solve. There's only one value for x. Maybe it could be more than one. Maybe, sorry, I should say, well, this one's only one value, but some equations could have like 2 or 3 values. But usually there's a finite amount of values for x that would make the equation work. An identity is when the left side is identical to the right side. So 2x plus 2 equals 2x plus 2, I distribute. They're identical. And that's what we want. When the sum is true for all values of x, that means the left side and right side are identical. So you have an identity. So you have to be able to recognize that first. Because then it's actually pretty easy. Because you could let x equal any number you want, like say 1, for example. You get a plus 2 and b plus 7. And here I get 15 plus c plus 14. Excuse me. So you get c plus 29 on this side. If I FOIL this, I get ab. Actually, before I get too carried away. No, let me do this. ab plus 7a plus 2b plus 14. And actually, I can continue simplifying a bit more. You get c plus 15, ab plus 7a plus 2b. It's still very complicated because there's a lot of letters involved. But they tell us this is a huge piece of information. A plus b equals 8. Well, if you think about it, if you were to FOIL before I substitute for x, if I were to FOIL ax with bx, you have ABX squared, which is, identical to 15x squared, right? Remember, it's an identity. So A times B is 15. And A plus B equals 8. So at this point, I realized, oh, then A and B will have to be 3 and 5 probably. So kind of backtracking a little bit, because that was kind of crazy when I did all that foiling. So maybe I do that. Maybe I'll just let A be 3 and B be 5. So 5 times 12 is 60. And that's C plus 29. So C is 31. And you can reverse A and B, and I think you'll get 7 times 10, which is 70. So you have 41 as well. So again, it's a tougher problem, but wanted to kind of have you guys see that. Okay. So I'm gonna, you see they do system of equations again here. So they really like that. So now I'm gonna devote our time to the math portion with the calculator. And we'll do this for about maybe 30 minutes or so. So let me go and stop this recording, start a new one.